part of the decision that Scandline had in equipping these additional 3 ferries with this system is the success that they had with the Princessa Benedicta, or however that's pronounced. Tell us a little bit about what their experiences have been. I'm curious as to what they have seen in the way of emissions reductions, improvements in fuel economy, if you can share that information.
I would love to be able to share all those details with you because it's very impressive. Unfortunately, due to confidentiality reasons, I'm unable to talk about the actual numbers.
Okay.
And, it's a very highly competitive marketplace that they're in. What I can say is that that industry will spend $1 million to save 1% of fuel. Okay, our system cost $4 million. And let's just say that they're very, very happy with the performance of it.
With the results, okay.
They're going to get far better than 4%. They're going to get upwards of, I believe, in the area of 10% or better right now, and we know that that will be optimized as it goes. The other thing that we need to remember is that they actually had specified, I believe it was one of their own press releases, that they've had the best fuel economy from that vessel ever in its history after installing the Corvus system on it. That vessel is 30 years old. So when I say fuel economy, that what they're talking about is the actual cost of operation. So if you can imagine what the price of fuel is now versus what it was 30 years ago, they're actually cheaper to operate that vessel now than it was 30 years ago.
Wow.
So that gives you an indication of how well that they've done with this. And that's why they're ordering 3 more boats.
Yeah, so what's typically the turnaround time? I mean, how long is the boat out of service to install a system like this?
Yeah, the first one was actually, I think our batteries were shipped to the dock and they were installed in about 6 weeks. And, a lot of that is attributed to the fact that we're working with some of the top integrators in the world. So we basically supply the energy storage system, inspect the charging systems and charging algorithms and everything else as a part of that. But what we also do is we work with a company called Siemens. You might have heard of them.
Yes, yeah. I was going to bring Siemens up. So
yeah, they're about 470,000 employees worldwide, and their marine division is very, very strong. In fact, they've got a really great product out now called the Blue Drive Plus C, and we're spec'd as the energy storage in that hybrid component of those vessels that they're doing going forward. This existing vessel used a combination of Siemens driveline systems and Kongsberg control equipment, but it's a 30-year-old vessel. So there were some challenges in regards to integrating a brand new system, which requires a completely different set of control systems or a completely different set of data points. Like I alluded to earlier, there's 120 different data points. I believe the original equipment could only carry about 25 of those. So they've had to upgrade some of the systems, but interestingly, they've managed to adapt and they've managed to make a very reliable, robust systems. And I think that speaks to the quality of the systems that were installed in the first place. Yeah. Obviously, commercial marine equipment is built to last. These vessels will have lifespan of 60 years or better in some cases. So the battery component took about 6 weeks. I believe the refit was a couple of months, maybe a little bit longer than that. And they're busy routes, so they want to turn them around as fast as they can.
Yeah, I should point out to everyone that according at least to the press release you sent out, that these vessels operate 24/7, 365 days a year on a 30-minute schedule. So these things are moving continually, and I assume that the least amount of time that they need to be down, the better.
That is absolutely correct. And we said 6 weeks on the first one, and that's where we came in. We believe that the second ones will be half that time, just because we know how it all goes together now.
Learning curve, yeah. Where do you typically install these? I assume when these things are engineered, they try to make the maximum use of the storage capacity for passengers and trucks and freight and things. So I can't imagine that this is going to be a relatively small little battery pack. This is a good sized unit. So where do you guys mount these things? Is it down in the engine room or how?
Yeah, we build a separate area for them with racks and whatnot. Because they're IP67 rated and they're so durable, we don't have to do any special enclosure for them. But we do like to keep them close to each other and close to the DC bus. So basically how it works is they'll take out, I believe in this case it was 2 full-size gen sets that became redundant with the energy storage system in place.
Okay.
And then that freed up a lot of space. They order just in terms of size, you can envision about a 40-foot shipping container is about how big a 2.7 megawatt hour battery pack is. So we can configure that. The nice thing about it, though, is that while we like to have them close together, given the spatial limitations on a vessel, we can be pretty flexible with how they're configured. So, the batteries are virtually maintenance-free, or they are maintenance-free. Once they're installed, you could essentially put a wall in front of them and leave them and forget about them. So they can place them around the vessel. Luckily, in this case, they were all very close together and very nice, neat and tidy rows of them.
Yeah, did it do anything with regard to the weight and balance of the vessel? I assume you want these things as low under below the water line for stability purposes.
Yeah. Yeah, a 2.7 megawatt hour battery pack is going to be around 30,000 kilograms.
Okay.
So it's not a light deal. If you compare that to lead acid, though, it's about 10 times lighter.
Yeah.
So, this is why these products are actually coming to fruition now. It's because the batteries that they had before were so heavy. They just simply weren't. You try to put that much in a vessel and you're going to sink it, or you're going to significantly affect the characteristics of how it handles. These ones are now doable because of the lightness of the lithium technology. For example, we actually had a vessel in Long Beach, California that had lead acid batteries in it. It was one of the first hybrids ever. She's the Carolyn Dorothy. And when we replaced her packs with the Corvus Energy packs, it came up out of the water about a foot. And so, that's, I think it was a 15,000 pound battery pack being replaced by a 2,700 pound battery pack.
Wow.
Yeah. So you can see that the vessel was originally designed not to have any batteries on board it at all. So they were very happy to get that weight back.
Okay, so when you focused in on the marine market, are there any other markets out there that look attractive for this technology? Obviously, you could say stationary, battery grid substation kinds of things. What other markets are you guys looking at?
Well, we're our product is over-engineered for a lot of the applications that are out there. This battery is so strong and so durable that it might be overkill for some of the applications, and as the price comes down, we're going to find more of them are applicable. Right now, we're focused on the high-power, extreme-duty type products. So another application is port cranes. The rubber-tired gantry cranes burn about 120,000 gallons of fuel a year.
Oh, sure.
We can basically take those things and put them in a hybrid form and save about 80% of their fuel. So huge savings, but huge emissions savings as well. The motive market, we actually worked with Peterbilt and PACCAR on their latest 2 super trucks. So the super truck program was American DOE funded project to basically provide high fuel efficiency for trucks, on-road trucks. And we helped them achieve that by providing a lightweight cranking battery and then a house load battery. Another one was the Walmart Wave truck, which is all over the news right now. It looks like a attack helicopter or something. But it actually is really interesting. It uses a capstone turbine to provide electricity to our batteries that then in turn provide propulsion for the electric motors on board. That thing gets around 17 miles per gallon. It's equivalent to what you might find in a typical mid-size SUV.
Well, yeah.
This is a Class 8 road-going truck, and so that's some of the stuff that we're working on. We also talked about the stationary applications. Because our batteries are so small and they're so robust, we can basically put a shipping container full of batteries in the middle of the bush and hook up a emergency hospital, or we could provide emergency relief to disaster or war-torn areas. We can basically, in some countries, they rely on diesel generation for their electrical grid. Nigeria is a prime example of that. They've got a huge disparity between the amount of consumption of power versus the amount of power that's available. And what happens is they actually will have these rolling blackouts. They have no idea when or where or how long the power will go out. And it could be every 2 days, or it could be once a day for 2 weeks. They just don't know. And it could go out for a few days at a time. So as a result, what they've started doing is basically every home and every factory and every business has a diesel generator running 24 hours a day, and they view the grid as backup. Kind of opposite to what we do. So we can actually provide a battery power solution that hybridizes those diesel generators. So the load, say the house, is now run off of Corvus Energy batteries. When the batteries get low, then they look for a source to charge them. If the grid's available, then that's the most cost effective. They just instantly charge off the grid. If there's solar, they'll take that because then we can install solar panels. If there's wind, we can use that. Or even run a river. We can run hydroelectric power. The input source doesn't matter. If none of those clean energy sources are available, then the diesel generator will get a signal from the battery saying, oh, time to turn on. It'll charge up the batteries. Because the batteries can charge very quickly, the diesel can run in its optimum RPM, once again, just like the ship.
Right.
Then, as soon as the batteries are topped up, it'll shut off again. And we installed one of those systems at a gas station in Lagos, Nigeria, and it has since become the most popular gas station in all of Lagos because they've got power.
It actually had power, yeah.
Power, you can't get gas out of it, so people always go there now.
Yeah.
And so the economic benefits go beyond the fact that they're saving between 50 and 80% of their fuel burn each month. It's actually because they've actually got the lights on, and people will come and do business with them.
Yeah. Wow.
So, those kinds of benefits, the way we look at it, Bill, is we call it sustainable capitalism. And, we can actually provide a real tangible economic benefit to our customers based on saving fuel. The fact that we're reducing the amount of emissions that are coming out of their tailpipe is just gravy. And that's really what drives us forward because, at the end of the day, when I'm tucking my little kids in and, saying goodnight, the fact is we're making the world a better place, and it's really nice to be able to do it and to make a profit at the same time.
Absolutely. That's great. Well, look, thank you. And let's talk at some time about my e-peddler project because I think I might have an application we can talk about. So
that sounds great. I always like to listen.
All right. Sounds good. Well, thank you very much. We really appreciate it. And we've had Grant. Come on. I'm going to cut this again. Thanks a lot. We've had Grant Brown with us. Grant is the Vice President of Global Marketing at Corvus Energy Limited up in Canada. And we're going to see more and more ships being hybridized to save fuel and cut emissions. So thanks, Grant.
Thanks a lot, Bill. You bet.
All right. Okay, bye-bye.
Bye-bye.